Okay, this little example is a bit of an extension on the linear regression example, but it's to illustrate a different point, a different take-home message, which is if you have some kind of model wherein you keep tweaking the model until you get to an optimal point, if you keep adding more degrees of freedom, you'll notice that the consistency radius drops down and stays down. So let me just show you this made-up example with polynomials, because you're probably more familiar with polynomials. This is what happens if I try to fit a line to a set of parabolic points, and I can go ahead and show you that it actually correctly fits a parabola. And here's my parabola, and you notice here what happened is your error went down to almost nothing, and if you go back to the linear model, then the error goes back up again to something that is non-zero. Okay, so you can see the error in different parts of this grid, your usual ANOVA grid, and you're used to seeing that. And then of course if you crank up the model, at a higher order, it'll just fit the points exactly again, because it's just going to zero out one of these coefficients. Okay, and the same exact thing happens when we run this in the Sheaf world. So here's the code for this. I'm going to let the user pick the model number 1 through 5, and then it's going to, based on which model is chosen, it's going to either build a constant, a line, a parabola, a cubic, or a quartic, and then it's going to let you see the consistency radius and all that jazz. So let's go ahead and run this. And if we try a constant, we see the consistency radius is pretty high. So the average value is 175. That's not very useful, but there you go. Pretty bad consistency radius relative to the ones we're going to be getting pretty soon. Let's see if we go ahead and put in a line. It's a little bit better. Consistency radius is 74. And we're going to do a parabola here, and we're going to see that the consistency radius is nearly 0 because the points I picked were exactly on the line. And here's our coefficients. Here's our 3x squared minus 2x and then plus 1. So we actually got the model correct. And if we increase that model up a level, okay, we can go ahead and do that, and we'll see we don't get any more improvement, and it's actually giving us the same model back out again, and one more, and then we'll stop there. But one more example just to sort of convince ourselves that this really worked, right? So the next two coefficients that were added to the model were essentially 0. They actually added more noise than anything, but it's still a very, very low consistency radius. So the fact that these consistency radius values dropped down and stayed down means that we were wasting our time adding more flexibility to the model, because we already had a good model at level 3. We didn't need to go up to level 4 or 5. So that's just an important takeaway. And Robinson has some nice examples with calculating how many stars are in an image that you might take of the night sky. So that's a really interesting example. But I just wanted this sort of simple example to sort of set your mind thinking about what it is that's going on when you keep adding more and more flexibility to a model and it isn't actually getting you anywhere. Okay, so hope that was fun.